Hey everyone! This video is designed to help you learn more about exponents. We'll go over some of the basics and how to evaluate exponential expressions. Let's get started. Exponents. An exponent shows how many times to multiply a base number by itself. Let's take a look at what that looks like. For example, this is 4, which is the base, raised to the third power, which is the exponent. This means 4 will be repeated as a factor, meaning we're going to multiply 4 3 times. That 3 comes from the exponent, and 4 times 4 times 4 is equal to 64. You read 4 to the third power as 4 to the third power or 4 cubed. Anything raised to a third power can be considered cubed. Here's another example. 5 to the second power. The base is 5, the exponent is 2. We will repeat 5 as a factor 2 times, and 5 times 5 is 25. You'll read 5 to the second power as 5 to the second power or 5 squared. Anything raised to the second power can be considered squared. 12 to the 0 power. Our base is 12. Our exponent is 0, and this expression actually equals 1. Because if a base is being raised to the 0 power, it will always equal 1. It doesn't matter what base we're talking about, any base raised to the 0 power equals 1. Here's an example of an exponential expression that we can evaluate. Notice again that the purple numbers are our bases and the exponents are in green. So this means only the 3 will be raised to the second power. Our base is 3. Our exponent is 2. When we rewrite this expression, this means we're going to multiply 2 times the product of 3 times 3. That's going to be 2 times 9, which will ultimately be 18. Remember, when evaluating an exponent only works on what it touches. In this case, the exponent was touching the parentheses, which contained only the 3. That's why we only squared the 3. Here's another example. In this case, again, the 3 is being raised to the power of 3. 3 is our base, and the exponent is 3. So, first we're going to keep the 2, and then 3 times 3 times 3 is how we evaluate the third power of 3. When we do that, we'll get 3 times 3, which is 9, and 9 times 3 is 27, for a grand total of 29. Remember, when evaluating an exponent, the exponent only works on what it touches, and in this case, it only touches the 3. Now you try. Here's another opportunity for you to learn about exponents. Remember, you can pause the video anytime, try the problems yourself, and then come back to check it out to see if you got it right. So in this case, 2 is our base, and our exponent is 4. This means we will repeat the base 2 4 times. And to make the multiplication easier, I like to group my numbers sometimes. So in this case, I'm going to do the 2 pairs of 2's first. 2 times 2 is 4, and 2 times 2 is 4. Then we can multiply those together to get our final answer, which is 16. Now you could have done 2 times 2, which is 4, and 4 times 2, which is 8, and 8 times 2, which is 16. Either way is absolutely acceptable, but sometimes it's easier to break down those numbers and multiply that way. Okay, try this problem. 5 plus 7 squared. Notice that 7 is the base, 2 is the exponent. This means that 7 is going to be the only thing raised to that power. So that can be written as 5 plus the quantity of 7 times 7. And we'll take care of 7 times 7 first. So that gives us 5 plus 49. And when we add the 2 of those together, we get a grand total of 54. So the value of this expression is 54. All right, guys, now you try. Here's the expression. Remember that you can pause the video anytime and try it yourself and then come back to make sure that you got it right. All right, in this case, notice that the 5 and the 7 are both purple. They are both bases. The sum of 5 and 7 will actually be the base, and the exponent will be 2. So 5 plus 7 is 12. That's our base. 12 squared is equal to 12 times 12, which is equal to 144. All right, how about this one? Remember to pause the video as needed. In this case, the base is 3 and the exponent is 2, and we're going to do that before we do the subtraction. So 10 is going to be subtracted by 3 times 3, which can be rewritten as 10 minus 9, which is a total of 1. How about this example? 10 minus 3 squared. Again, the base is that entire expression, and the exponent is the 2. So first we subtract, leaving us with a base of 7. 7 squared is equal to 7 times 7, which is equal to 49. All right, try this one. This is 2 minus 2 to the 0 power. Your base is 2, your exponent is 0. So this will end up being 2 minus 1, because remember, any number, no matter what it is, any base raised to a power of 0 is equal to 1. And 2 minus 1 is equal to 1. Remember, if a base is being raised to the 0 power, it will always equal 1. Don't forget that. It doesn't matter how big that base is. If it's raised to a 0 power, it is equal to 1. All right, now let's look at all the different ways that we can write exponential expressions. So we have exponential form, where we write it with a base and an exponent, in this case 2 to the 5th power. Expanded form is where we take that base and we multiply it out the same number of times as the exponent. So in this case, 5 times. Note that the dot that is between the factors is the same as an x. It means to multiply. And standard form is where you actually do the multiplication, 2 times 2 times 2 times 2 times 2, to get the standard form or the value of that expression. Here's another example. Y to the 4th power. In expanded form, that is y times y times y times y. In standard form, we actually don't have a value for that unless we know what the value of y is. In its current form, I cannot give you a value or the standard form for this expression. But if we know what y is, we can substitute it in to get the value. In this case, 9 squared. Expanded form will be 9 times 9. Standard form then will be 81. 10 to the 0 power does not have an expanded form because there's no factors to repeat. And remember that anything raised to the 0 power is equal to 1. And finally, 3 to the 6th power means that we repeat the factor of 3 6 times. And when you multiply that out, you end up with 729. All right, you try. The first one, I've given you the exponential form. See if you can figure out what it will look like in expanded form and what its value will be. Remember, you can pause the video at any time to make sure that you do the problem first and then come back to check your answers. So 6 to the 3rd power in expanded form will look like this. 6 times 6 times 6. When you do the multiplication, you find that the value is 216. In the second example, I'm going to give you the expanded form and see if you can work backwards to get the exponential form and then find the value. So there are 3 factors of 10. The exponential form of this expression is 10 to the 3rd power, and its value will be 10 times 10 times 10, which is 1,000. Try this one, 4 to the 2nd power. In expanded form, it will be 4 times 4, so its final value, or its standard form, will be 16. And in this example, we've got x, and there are 6 of them. So the exponential form will be x as the base to the 6th power. And its value will entirely depend upon the value of x. If we know what x is, then we can compute the value. If not, there is no standard form for this expression. And finally, 90 to the 2nd power. That can be written as 90 times 90, which ultimately will be 8,100. All right, here's your exponent summary. An exponent shows how many times to multiply a base number by itself. Sometimes exponents can be called powers. An exponent only works on what it touches. Any number raised to the 0 power is equal to 1. And we can write exponential expressions in exponential form, expanded form, and standard form. Hope this sums up exponents for you, and see you soon.